Hello class, today we are going to be learning about wave interactions, and I've just created this little PowerPoint to kind of give you some background information, kind of let you know what you're going to be learning about, since we haven't really talked about this topic in a whole lot of detail yet. There are 4 ways a wave can react depending on the boundary it encounters. These 4 ways are absorption, reflection, refraction, and diffraction. But we are primarily just going to focus on the following 3, which are reflection, refraction, and diffraction, because those are the 3 that we're to focus on for NGSS purposes. So let's start with reflection. Reflection. The definition of reflection is when an object or a wave hits a surface through which it cannot pass, it bounces back. There is also a law of reflection, which we will also study, and this is the angle of incidence equals the angle of reflection. We will actually do a lab on the law of reflection in the coming days. What are some examples of reflection? Well, in this example, we can see the reflection of Mr. Whitley's computer screen reflecting off his glasses, which is a hard surface. Now let's talk about refraction. Refraction. The definition is the bending of waves due to a change in speed. When a wave enters a new medium at an angle, one side of the wave changes speed before the other side, causing the wave to bend. Here are some examples of refraction. Over here we see a straw being inserted into a glass and how it looks like the straw has bent, but really we know that it's still our full straw. This is just an example of refraction. Here we have another example where this girl is looking into some water, and it seems like the fork is over here, but really the fork is right here. And then here we have another example of an older man sitting in a tub of water or a pool or whatever this is exactly, and he must love science because he's got a physics is fun sign, and it looks like his head is separate from his body, but this is just another example of refraction. Let's talk about diffraction. Diffraction is when a wave moves around a barrier or through an opening in a barrier, it bends and spreads out. So what are some examples of this? Here we have a CD, and we have light reflecting on the CD, and the light is trying to go across the CD, but we can see right here we have an opening. The light still goes across, but now it has been diffracted, and so it looks differently. Same with a projector. The light has to come through this little opening to be projected onto the board, and this is another example of diffraction. With waves, we have another example of diffraction where out here we have the whole ocean, and then it's being diffracted through this small opening here into this little bitty pool, and that is another example of diffraction. Now let's talk a little bit about interference, because that is another thing that we will begin talking about in the coming days as well. So, definition of interference is the interaction between waves that meet. And there are 2 types of interference. The first one is constructive interference, which is when energies are being added. This occurs when waves combine to make a wave with a larger amplitude. So think constructive means bigger. The second type of interference is destructive interference, which is the subtracting of energies, and this occurs when 2 waves combine to make a wave with a smaller amplitude. So destructive, think about when you are being destructive, you're tearing things down, you're making things smaller, and when you're being constructive, you're constructing something into a larger version. Here's an example of constructive interference where you're making a small ripple and then you're making it become a bigger ripple. Here's just a little illustration where we've got 2 waves that are constructing together and they've created this big wave. And then here you've got destructive interference where they're crossing paths but not joining up, and so they eventually just cancel each other out. And that's all for today.